And welcome, ladies and gents, here to help you with Chapter 5, Lesson 8, Chapter 5, Lesson 9, Equivalent Fractions in Simplest Form. Now, we have done a quick homework review on Friday, but I wanted to include these answers. Pause, come back if you're ready to move on. That's assignment 10. Here's assignment 11. Pause, come back when you're ready. So, want to just briefly talk about where we've been and where we're going. We have done equivalent fractions before, whether using prime factorization or not. We should be able to say 3/4 is the same as how many 16ths, but of course, naturally, we're going to move into algebraic fractions because next year and in years after, you should be able to compute or simplify algebraic fractions. That's where we're heading. But for today, let's just talk about how to write those equivalent fractions, as well as how to simplify or reduce fractions to simplest form. I will go over this in class. No need to write this down unless you'd like to. And so here we go. Some basic review. Equivalent fractions, let's talk about it. If this apple were cut along the dotted line and you took one piece, what fraction of the apple would you have? Well, naturally, that would be 1/2, 1/2. If the bottom apple were cut into the dotted lines and you took two pieces, what fraction of that would you have? Well, as you can imagine, it's the same amount of apple. It's just two different ways of representing, or should we say slicing it up. 1/2 is the same as 2/4, and your belly does not know the difference. That's what equivalent fractions mean. Now, 1/2 is the same as 2/4. 1/2, 2/4 also the same as which of those bottom two? I have a hunch that you can easily identify. I'm not really sure what this fraction is, but if we looked at an estimate, it clearly does not appear to be 1/2 of the fraction. Now, to find equivalent fractions, remember, please, as often is the case in mathematics, it's really all about fairness, right? So if you multiply 3/5 by 2/2, first of all, why is that okay? Well, consider, please, that 2 divided by 2 is still a whole, right? And if you multiply anything times one whole, you still get the same amount. So that shouldn't really change the amount of apple going into your belly. So 3/5, if you multiply both numerator and denominator by 2, you would get 6/10. Now, just to be clear, 3/5 of an apple, the same amount as 6/10. In like manner, 4 divided by 4, in fact, any number divided by itself, with one exception. I don't know if you guys know the exception. 4/4 is a whole. 3/5 times a whole is still 3/5. So you could say that 3/5 is the same as 12/20. All of these fractions are the same amount of apple going into your belly. They're just different ways of representing or slicing those apples up. So in this case, then, how do you figure out 2/3 is the same as how many 12ths? Some of you know this. You might want to skip through this, fast forward. If you say to yourself, okay, 3 times how many parts gets cut up into 12? Well, that would be 4 parts. Let me put a quick, rather ugly picture here. If I were to highlight 2/3 of this, and I say, okay, but we don't want 3 slices, we want 12 slices. Well, then each of these would have to get cut up into 4 parts. 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. Now, please notice the highlighting did not change. The amount of chocolate bar did not change. We just cut it up into smaller sizes of chocolate. So 3 times 4 is 12, 2 times 4 is 8, and therefore 2/3 is the same amount of chocolate as 8/12, just different size slices or different ways of representing it. In like manner, sometimes you don't want to make more pieces. Sometimes you want to group them up, make less pieces, if you will. So if I were to draw out 6/10, might say, okay, but can we group those up more? Can we split 10 and 6 into the same number of slices? And in this case, we can. We can group those into 2s. Now notice, please, by grouping or dividing them into 2s, we now only have 5 total slices, and of the 5, 3 are highlighted. Again, kind of a weird thing. It's the same amount of chocolate, it's just different size slices. 6 out of 10 pieces is the same as 3 out of 5 pieces. So you may multiply to get more pieces, smaller slices, or you may divide to get bigger slices and therefore less pieces. In this case, you may either go to the left or to the right. I'm not really happy with going to the left personally, but you can think of it as dividing, or you can go the other way and say 4 times what is 16. And in this case, it'd be multiplied by 4, and therefore 3 times 4 is 12. Now, of course, things are going to get a little tougher, aren't they? What if? What if we have variables in the expressions? To which I would respond, don't worry about it. We know how to handle this. We can do this. I'm going to ask, because 5 must get cut into more slices to get 20. 5 times what is 20? Well, in this case, 5 times 4. And of course, we'll be fair to the numerator. But that is not good enough, because we also have to change AB to get A squared B, which I guess means we need to multiply by another A and be fair to the numerator. So just to review, 5 times 4 would give us 20. A times A would give us A squared, and then there's the B at the end. So let's go ahead and be fair and multiply both numerator and denominator by 4A. 4 times 4 is 16A. And now we have an equivalent fraction where 4 over 5AB is the same amount as 16A over 20A squared B. Let's do the same thing for the next problem, where we want to find an equivalent fraction to 7 over 8xy. We want 24. 8 times what is 24? Well, that would be times 3. But we only have xy, and we want x squared. I guess we're going to need an extra x. And we want y squared, so we're going to need an extra y. So let's go ahead and multiply both numerator and denominator by 3xy. Now, just to be clear, 8 times 3 is 24. X times x is x squared. Y times y is y squared. So that checks out. Meanwhile, 7 times 3 is 21 times x times y. There's no simplifying. And therefore, we have now found 2 equivalent fractions. 7 over 8xy is going to be the same amount as 21xy over 24x squared y squared. Now, again, we don't know what x and y are. It is a mystery. But at least we know that whatever x is, whatever y is, as long as x and y are not 0, because you cannot divide by 0, you cannot have 0 in the denominator of a fraction. You'll hear more about that in the algebra class. Anyways, no matter what x, y is, as long as they're not 0, then those two quantities will be the same. Now, if you'd like, go ahead and review that last slide, rewind, listen to it again. Let's go ahead and simplifying. Now, if you have the skill where you can immediately find the greatest common factor just in your head, then you may go ahead and do so. But if that doesn't work, sorry about the phone in the background, then in that case, you may have to say, okay, 15 can be broken down into 3 times 5. 24 can be broken down into 2 times 12, which is the same as 2, times 6, which is the same as 2, times 3. You guessed it, you're looking once again at the prime factorization. And now you can find that greatest common factor. Now what's also interesting is if you were to divide by 3, look at the equivalent fraction where 5 is in the numerator and 2 times 2, which is 4, times another 2, which is 8, is in the denominator. So it can help you to quickly find A, the greatest common factor, or B, the equivalent fraction by looking at whatever factors remain. Now 32 and 20, let's say you mess up and you reduce by 2. That's not a mess up, but can we just say that that is not yet in simplest form? We can reduce by 2 again and get 8 over 5. And while that's acceptable for our current process, sooner or later we will discuss the fact that that is the same as 1 whole and 3/5. But again, when in doubt, you may always go to the prime factorization. 2 times 2 times 2 times 2 times 2, check it out, that is 32. 20 will be equal, I should say equal, to 2 times 2 times 5. And would you look at there? They both share 4. And if we would have reduced by 4 from the beginning, then that would have saved us time going straight to simplest form, if you can identify the greatest common factor. One way or another, we got different paths that lead us to the same destination. I don't care how you get there, as long as you get there, but you probably know what's coming. Can we simplify fractions with algebraic terms? Now, again, some of you can simply find the greatest common factor, but for the rest of us, we really should write the prime factorization of each term. So 8x squared can be rewritten as 2 times 2 times 2 times x times x. Don't forget, if you get stuck, you're welcome to do the upside down division, or I've seen some of you do factor trees to find all the prime factors. Meanwhile, 6, sorry about the color, 6xy can be rewritten as 2 times 3 times x times y. Now go ahead and look. There's the 2 and the x. So what we really should divide both the numerator and the denominator by is 2x. Now, if we were to divide by 2x, 8 divided by 2 is 4, and x squared divided by x, remember that any number divided by itself, except 0, cancels out. So we have x. No need to write the 1 in the numerator. If you wish, you may. Meanwhile, let's look at the denominator. 6 divided by 2 is 3. X divided by x will completely cancel out. Imagine that, x divided by x. That will completely cancel out, but we are left with the y in the denominator, 4x over 3y. Now look carefully at the answer, ladies and gents, and what do you notice? 4x. 4x. Factors are remaining if you were to simply cross or divide out the greatest common factor. Look at the denominator, 3y, 3y. So you may use the prime factorization to help us. Let's go ahead and do the same thing with this second example. 9rs is the same as writing 3 times r times s. 24r squared. 2 times 12, which is 2 times 6, which is 2 times 3. There is the prime factorization of 24. And then r and r. And so we can now identify the greatest common factor of both numerator and denominator will be 3r. And if I were to write divided by 3r or divided by 3r, perhaps you can already see by what we have here, 9rs divided by 3r. 9 divided by 3, r divided by r cancels out, and all that remains is 9s. 24 divided by 3 is 8r squared divided by r means one of those will cancel out. 2 minus 1 is 1. You may write the 1 if you wish, but there's no need. And there is our equivalent fraction in simplest form. Just a brief preview of where we're at, and I will be reteaching this in class. That's what I have, folks. Enjoy and let's grow.